Hi, my name is David Nishagen. I'm the executive producer of Minecraft Dungeons.
And I'm Sean Farkas. I'm a developer on the Xbox game streaming team. We'd like to share our experience in making Minecraft Dungeons play great on mobile devices using Xbox game streaming. But before we get into how we did that, David wants to give a little bit of context as to why we would do so in the first place.
Yes, so let's start at the very beginning. It's all about the games, right? So Minecraft Dungeons, it's an action-adventure game. It's inspired by classic dungeon crawlers. Up to 4 players can play together and battle together through action-packed, treasure-stuffed levels, all on an epic quest to take down the evil arch-illager and save the villagers. So it's quite different from Minecraft. Why would we do a new Minecraft game? Well, the objective is rather simple. It is to bring in new players to the Minecraft franchise by providing new and different experiences. Now, a simple objective does not mean it's trivial. Minecraft is a pretty big game. We have sold well over 200 million copies, and we have well over 100 million monthly active users. So Dungeons, Minecraft Dungeons, as a new game, really needs to be where the players are. And at launch in late May 2020, we targeted a broad range of platforms, Windows 7 and Windows 10, the Nintendo Switch, the PlayStation 4, Xbox One, PC and Xbox Game Pass. And we're prepared for the PlayStation 5 and the Xbox Series S and X in the fall. But there was one key piece of this platform puzzle missing. There's a lot more phones than there are game consoles and gaming PCs. Doing a native mobile port of a console game is difficult and perhaps even impossible, pending the feature set.
So, enter Xbox game streaming. And since the servers that power Xbox game streaming, they're really just Xboxes, racked up and hosted in our Azure data centers, Xbox games can be streamed without any modifications. However, we really wanted to optimize the experience that Minecraft Dungeons players had when they were streaming their games to their mobile device. So the first thing to do was to set the team at Mojang and 011 up so they could experience their game as it was unmodified, getting an idea of how it played and what areas they might want to optimize. So to do that, the first thing we did was set up a private offering. And what that does is it gets Minecraft Dungeons onto the Xbox game streaming service, but set up in a way that only the people the development team authorizes has access to see that it's on that service. And with that in place, the team working on the project got together and they were able to stream Minecraft Dungeons to mobile devices and play it with a Bluetooth controller. Now, of course, as soon as we're able to play the game, we started making notes about optimizations that we might want to make. So our next step is to enable game streaming on the Xbox development kits. And we could use the content test application, which is effectively just a variation of the standard Xbox game streaming app with some development features in it that allow you to access these private offerings and connect to dev kits. We use that content test application to connect back to the Xbox development kits on our desks and see exactly how each change being made performed locally without needing to go ahead and deploy it into a data center first. And with that set up, it was time to go implement some of the changes that we were making notes about earlier. Now, one of the first things that we notice when we stream games is that on a mobile device, there are just some interactions that feel much more natural to do with touch. When I see a menu like this, I naturally want to interact with it by tapping on the screen. In fact, I've been working on Xbox game streaming since the project started. And when I see menus like this, I still find myself reaching for the screen, even though I knew at this point, intellectually, we had not done any work to touch enable Minecraft Dungeons. So, this seems like a really obvious first place to get started. Xbox game streaming uses the standard Xbox input APIs to route touch inputs to the game. Since Minecraft Dungeons is built on the XDK, we get an on-pointer press event, and we can check the pointer device type to see if it's touch as opposed to something like mouse. We can then shuttle that event off to the game logic to handle. Of course, if Minecraft was written on top of the GDK, then we would have a similar API available to access native touch data there. Minecraft Dungeons runs on the Unreal Engine, and so we need to do a little bit of mapping between the touch points that the Xbox is reporting to us and the touch points that Unreal wants to interact with. The first thing we need to do is go and update the coordinate system. Xbox touch points are always reported back on a 1920 by 1080 coordinate system. But if the game is rendering in a different resolution, for instance, maybe it's running at 4K, we need to rescale that touch point so we know exactly which pixels the player is tapping on. Unreal also expects that all of the touch indexes are between 0 and 9, whereas the indexes reported back by an Xbox are going to be steadily increasing. We need to just keep a map between the Xbox index and the one that in the 0 to 9 range that we've reported to Unreal. And that way we can make sure that Unreal is happy and we've got a good set between the two. Unfortunately, it's not as simple as just using a modulus operation, because you can imagine a scenario where a player has their finger on the device and is repeatedly tapping with another finger. If we mod the Xbox operation, we might reuse the first finger instead. So we need to keep an actual map on the side. The code is fairly trivial. And once we have that adaptation layer in place, we can route those touch events through the Unreal message handlers. And that's going to cause much of the standard Unreal touch handling code to just kick in. With that plumbing in place, touches will just route to UI elements. Buttons are tappable. Sliders can be grabbed and dragged around. Things basically just work as you might expect. But we can do a step better. We can detect we're streaming and increase the size of the buttons in the menu. And that makes for a larger hit target for touches on a mobile device. Now, this sort of thing can be done with just a simple call to one of our APIs that gets you the physical dimensions of your game as it's being rendered on your player's device. And that allows you to make decisions about how you want to best scale your UI for the different size devices your players might have, be it a phone, a tablet, or anything in between. We also made a few other changes here. We've removed the tooltip that suggests you use a controller button to dismiss the menu, and instead added an on-screen button that you can tap to get out of the menu and back into the game without needing to press B on the controller.
So some context here then. We rescaled pretty much all of the UI in the game, both for readability on like the smaller screens, but also for people with, fat fingers like me. This was one of the major concerns we had. We have several people in the dev team who have a mobile development background. And without the physicality of having a controller, it's so important that we get the touch input just right. It needs to feel right. And we're super happy that we have the technology to make this happen.
With the basics of touch routing done, the pieces were also in place to enable some more advanced scenarios for touch. So for instance, we were able to go into the inventory screen and plug touch inputs into place, making it so that we could scroll through that inventory list and use drag and drop to select gear and artifacts for use during gameplay. In addition to building elements into Minecraft Dungeons that respond to touch natively, we also used the touch adaptation kit to build touch controls for use in-game. And what the touch adaptation kit does is it lets us define a set of controls that the Screaming app is going to render. And then it sends those inputs from those controls back to the game as if they were from a standard Xbox controller. This means that we didn't have to build touch overlays into the game itself. because they're being rendered by the game streaming app. And it further means that we didn't have to touch any of the input handling code in the game, because again, the touch adaptation kit is interpreting the touches on our behalf, and the inputs look exactly like they're coming from any other Xbox controller. So let's walk a little bit through the design process of this layout. Now, we started out by mapping out all of the controls that might be needed during gameplay and finding a good spot for them on the screen. Our general idea was that we would have the primary actions, your attack, your use of artifacts over on the right side of the screen, and movement and some of the secondary actions over on the left side of the screen. We also selected from the icons that come built into the touch adaptation kit to mark each button so that the player had a hint as to what the button was going to do during gameplay. And once we had that initial layout built, it was a simple process to deploy it into our private offering and take it out for a test run. A few things became immediately obvious after playing it for a few hours on this initial design. A lot of us were accidentally hitting the map button in its position off to the left of the joystick. And this isn't great, because in Minecraft Dungeons, the map is going to pop up over the action. And maybe you're right in the middle of a fight and it's obscuring what you're doing. So our solution was to move that button above the joystick, where it's much less likely to be accidentally hit. Now, having the heal button near the joystick turned out to be troublesome because oftentimes you need to heal your character while you're also moving away from some danger. The solution here was to move it over to the right side of the screen with the other actions. Now you can continue to use your left thumb to move away from whatever's attacking you, and use your right thumb to heal up. The buttons to trigger the artifacts were difficult to use when they were shifted so far away from the main melee and ranged attack buttons. And so instead, we moved them from being grouped together to spread out around the main melee button so that they are much more ergonomically accessible during gameplay. It turns out usually when we're playing, our thumb is over that ranged or melee attack, and having the artifacts close by makes them much easier to use. One of the more obvious things that came up was that we had accidentally forgotten to create a button for the inventory screen. That button we added just opposite the map on the left side of the screen, and again, in a position where we hoped it would be much less likely to be interfered with from the joystick. We also added a couple of multiplayer buttons on the left side and wound up with a layout design that played much better than our initial attempt. There was just one more thing left to tackle.
Minecraft has a unique look, a pixel-style look. And making all Minecraft products instantly recognizable as, well, Minecraft, it's something we at Mojang take very, very seriously. Also, there is no guns or bullets in Minecraft, so we really need to make sure all the icons, all the UI is on brand.
So we put some custom artwork into place, and we landed on our final set of touch controls. But how did we build that custom artwork? How did we get that set up? Let's go into a little more detail on this bit. So in order to enable the touch controls to fit in with that Minecraft branding, we built a feature where touch layouts can use custom art assets instead of picking from the set of pre-built touch adaptation kit icons. Now, you can, of course, continue to use those icons if you'd like. However, you now have the ability to specify foreground art and background art for buttons and joysticks. Here, we're using the cleverly named inventory art for the foreground of the inventory button and a hexagon for the background of that button. Now, assets they're just PNG files. We bundle them up with the layouts that reference them, and they get provided in a variety of multiples of their base resolution. When the game is launched, the Xbox game streaming app goes ahead and it detects the DPI of the device the player is playing the game on. And with that information, it picks the icon that best matches that device. Your game doesn't have to worry about that at all. All you need to do is provide us art assets at these different resolutions. The app will take care of the rest. Now, Another thing to notice here is that we've combined a foreground image, a background image, and an opacity together into a visual state. Here we've just set up the default state. However, the touch adaptation kit supports some more advanced scenarios. Depending upon how your controls are going to be interacted with, you can build something a little more interactive. So for example, in Minecraft Dungeons, we provided 2 versions of each asset for the buttons. We have a pressed version and an unpressed version. And we put these together in the idle and activated state. What the touch adaptation kit does is when it initially draws the button, it'll draw the idle version. When the player interacts with that button, it'll draw the activated version. And when they release the button, it draws the idle version again. And by providing custom art for each of those 2 different versions, we're able to make it such that the button looks like it's being pressed in the visual style that makes the most sense for the game. Another thing to note here is that we built the A button tooltip directly into the art asset. And that enabled 2 things. It enabled us to style it so it fit best in with that Minecraft Dungeons branding, but it also enabled us to toggle it with the button press. So it really felt like it was a part of the button and not just tacked onto the side.
So we had one more concern from the game team. We know that after the rapid iteration, we got the layout, right? But touch input requires this strong visual feedback since you can't have the physicality of the buttons. So you need to really understand if a button is pressed or not. So, and also doing that without looking at it, even in a peripheral vision, right? So, of course, your fingers are also covering most of the buttons. So they really need to be, buttons and their states, they need to be clear and they need to be large. But if you cover your entire small screen in large buttons, it can become quite overwhelming.
The Squid Coast level in Minecraft Dungeons tutorializes the game's mechanics by slowly adding in ideas as you progress through the level. We wanted to do the same with the touch layout, adding in controls as you progress through and have those concepts introduced to you. We wanted the on-screen touch controls to effectively match the concepts that the game is introducing to you as you're walking through the level. So therefore, we started with a layout that has just movement and melee controls available. Once the player gets their bow, we added the ranged attack button. And finally, towards the end, when the player gets their first artifact, we want to add in the X, Y, and B buttons so that they can use items out of their inventory. Now, one way to do this would have just been to have multiple different layouts. Each one could successively add new controls until the full set is available by the end of the level. And that would definitely work. But thinking about it, it really doesn't scale very well. It involves a lot of duplication of layout code, and that makes it more difficult to make a change later. We talked earlier about how we took several iterations through the design of our touch layout before we landed on the final version. If in the tutorial level, we had multiple different versions that all needed updating every time we made one of those changes, it's just that much extra friction to get those changes pushed through. So the alternative is to use a more advanced feature of the touch layouts called variable replacement. And what this feature does, it allows you to toggle certain properties of touch controls from the game, managing things like the visibility directly from your game's code. The first step to do this is to update your layouts to make a reference to the variable that we're going to be managing. These variables are all defined in a file named context.json, which it contains the definitions of all of the state that might be managed during the gameplay from the game and consumed by any of the layouts. In this case, we reference a piece of state named inventory slot 1 visible, and we bind that state to the visibility of the X button. Now our context.json file is fairly straightforward. We just define the variables we want to keep track of, and we give them their initial values. Here, we say that the inventory buttons, they should all be visible unless the game says otherwise. And finally, we can just go to the game code. and have it update those variables as we need. So maybe in that Squid Coast level, we might start with all of the inventory slots marked as not visible. But when the player grabs their first artifact, we can run code that updates that visibility of the X button, as well as the Y and B button, to be true. And that will cause those buttons to appear on the screen for the player to begin to interact with. And the net effect of this is that it allows us to use only a single layout for the tutorial. All of the buttons are there on the layout, but they're made invisible until it's time for the player to interact with them, at which point the game can just make the button visible again.
So we've now shown how we went about taking Minecraft Dungeons from a console game to a really great experience on a phone, playable fully with touch input, UI and UX rescaled to fit the smaller screen and, fat fingers, and custom assets to have a genuine Minecraft look and feel throughout the game. Early in the project, we also thought about doing this native port, but the game really shines in multiplayer, and it's a peer-to-peer multiplayer game. And there's just no way we could make a mobile act as a server without, melting the CPU. But by using game streaming, this whole problem just went away. Like, the Xbox and the data center is obviously fully capable of running and hosting an online multiplayer session. It just worked out of the box. So how much work did all this take? Well, we set up the initial teams in late June 2020.
We created the private offering on July the 2nd.
And the first commit that we did was August 3rd. And note, Mojang in Stockholm and our partner Double 11 in Middlesbrough in the UK, we both have rather extensive vacations during July. This means that the vast majority of looking at the game, tweaking, running the iterations and building, etc., that happened in August.
And in fact, feature development was complete by September the 7th.
And we launched on the game streaming beta September 15th. We brought the game to mobile in just a few months. And we did this work simultaneously with a major game update on all these platforms, plus a physical retail release with a small dev team. So the talent working on game streaming on Double 11 and Mojang was 2 producers, 2 UI and UX developers, and 1 reviewer to keep iconography on brand, and 3 developers.
Now, since it launched into Xbox game streaming, Minecraft Dungeons has consistently been one of our top-ranked titles across a variety of different metrics. It's one of the first games that people try when they first try out game streaming. And this applies to both existing Xbox players as well as people who are new to Xbox. Now, not only is Minecraft Dungeons one of the games that people try out first, but by their 3rd week of using Xbox game streaming, it ranks among the top titles that people are continuing to play. Minecraft Dungeons also consistently ranks very highly for the number of unique players who stream the game and the number of hours they spend streaming the game on Xbox game streaming.
Also, we immediately saw positive feedback from fans and players. The game looks, feels, and plays great. And before we launched, we frequently got the request, please take the game, please take it to phones. And now the fans themselves are saying, yes, it is on the phone. So I genuinely recommend that you reach out to your account manager and get a private offering set up. It's literally the definition of low effort, high impact.